Today we are going to discuss about the second part of unit current electricity, and in that part we will discuss about the electrical network. And the topic starts from Kirchhoff's law. The first we will try to understand what is Kirchhoff's law and how many types of law the Kirchhoff has given to solve the electrical network. Kirchhoff has given basically the two laws for solving the electrical network. His first law is known as point rule as well as junction rule. Point rule says that at any junction, the net current is always zero. Net current is zero. That basically means that at any particular point, sometimes from any particular path, currents are reaching at that point, while from the same point, the current may leave in another path. For example, we are taking here first law. Suppose that this is a point and there are few paths. This is the point O. You are observing here that to reach the point O, there are paths 1, 3 and 5. These are carrying current, but these are entering current. These are coming towards O. While there are two paths, this one and this one, through which currents are resetting the junction. According to Kirchhoff's first law, the net current at junction O is always zero, because as per the statement, net current meeting at any junction is always zero, and hence the net current at any junction O is zero. But remember, there are 5 currents which are related to point O. Out of that 5 current, 3 are reaching at the point O. If the entering current is taken as positive, then the resetting current will be taken as negative. If you are taking incoming current as negative, then the resetting current will be taken as positive. Whatsoever you can take. Generally, incoming current is taken as positive, and that's why we will take positive sign for I1, I3 and I5. So I2 and I4, I4 is also entering, let it be it is resetting, so that 2 will be resetting current and 3 will be incoming current. So I1 is positive, I3 is positive, I5 will be positive because they are entering current. I2 and I4 will be taken as negative. Why take negative? Because these are resetting current. This means I1, I3, I5 is equal to I2 and I4. From this you can conclude that net incoming current is equal to net outgoing current. The first law, which is also called point rule or called junction law or junction rule, says that the net current meeting at any junction is always zero. From that, we are concluding that net incoming current is equal to net outgoing current, but this will be valid only for the junction, not during the path or in between the two junctions. It is possible only for the junction, for the point, and that's why it is called junction rule or point rule. Similarly, Kirchhoff has given the second law. That second law related to again electrical network. but electrical network basically means the closed path. So his second law is related to closed path. That's why it is called mesh law or loop rule. Right? So we are going to discuss about the second. As a statement, we can say that the net potential drop across any particular loop must be equal to net EMF in that particular loop. So, as a mathematical expression for second law, we can write summation of E is equal to summation of IR. Sometimes we also express it in this way. If we are taking this one, this means first of all you have to take the net EMF in that loop which you are considering, and that must be equal to net potential drop across different arms of the same loop, and you can equate it. If you are taking this one, summation of B is equal to 0. This means you will start from a particular point and again reach to that particular point, and the sum total of all the potential drop, whether it is EMF or potential drop, it hardly matters. The sum total of all the potential difference from point to last point, that will be equal to 0. To express the second law, we are taking a circuit. This ABCD is basically a loop carrying some cell as well as resistance. We are taking only external resistance, no internal resistances are there. This one is the first cell resistance. So there are E1, E2 up to E5, E4, and one path is there where only resistance is there, no EMF is there. But first, to apply the second law, we must know which part you are basically utilizing. With the summation of E is equal to summation of IR or summation of B is equal to 0. First you decide yourself which you would like to apply. According to that, you will use sign convention. So I am using here summation of E is equal to summation of IR. We must know here that there are sign convention too. Sign convention for current and sign convention for EMF. The direction in which we move, suppose I am taking a loop AB, DA. If I am taking AB, DA, that means I am moving along A to B, then B to D, then D to A. I am moving from A to B, B to D, A to A. This is called direction of traveling. This is called direction of traveling. And there may be current also. Suppose I am starting to provide current, distribution of current I am taking from this particular one. You may take from any cell, hardly matters. So let the current starts from cell 1. It moves along this path, there is no junction, so same current will flow here also. The same current will come here, but again it is getting two paths, so one will move along this, and a part of this current will also move along this path. So I1, I can say, is equal to I2 plus I3, because this current is basically distributing according to first law. The net current at any junction must be same. So current entering at D is I1, but from D there are two paths to move forward. So if any current this is passing, I2 is flowing in this path and I3 is going through this path, that means the sum total of this outgoing current must be equal to incoming current. So we can write I1 equal to I2 plus I3. This is the first law we are applying. So this path also has some current. Now if we are moving from D to C, it is called direction of traveling. We are observing here that direction of current is also moving along D to C. So direction of current is called DOC, and direction in which you are taking the loop or you are moving, that is called direction of traveling. So same current I2 will flow in this path also. At the point B, I3 is coming from this path, I2 is coming from this path, both will add to give I1 and the same current will flow through this. Remember always that in particular path there cannot be two different magnitude of current. For example, if you are going from D to C, it has only one current I2. Never distribute like that one current is coming from this side, other is coming from this side. It will not happen. Number one. Number two, it is also not possible that a current I2 is flowing in this path and another current I3 is also flowing in the same path. In between the 2 points, one current having only one magnitude will flow and only along one direction, not have two directions. So this is called direction of travel, direction of current. For current, if dot direction of current and direction of traveling both are same, then I will be taken as negative. Right? If dot and dot are opposite to each other, you can take positive. That means dot and dot if match, you can take positive or negative depending upon you, but select only one and according to that the second will change. I will suggest that if dot and dot will match, then you take positive. It will be easier for you. So this time I'm taking dot and dot are matching, that's why I is positive. And in case of dot and dot are not matching, I will be taken as negative. Now for EMF, whatever the dot is there hardly matters. If you are going from A to B, so your dot, this one, is from A to B. So you are touching first positive terminal and then entering into negative. Depending upon the exiting part, you will take the EMF. If you are moving from A to B, you are leaving the negative terminal at the last, so EMF will be negative. If you are moving from B to A, you are leaving last the positive terminal. That means it will be positive. EMF will be positive. So these two are the sign convention. On the basis of this, I will apply Kirchhoff's first and second law in the loop, whatever we select. Suppose we are taking ABDA. So now apply your Kirchhoff's law in ABDA. First of all, I will use EMF. So from A, we are moving along B. One EMF is there. Since we are moving from A to B, so negative terminal we are exiting. That's why it will be taken as minus. Now I have gone to B. Now B to D. B to D, there is no cell. So no EMF is there. Now we are going from D to A. Again I am crossing through negative terminal. So that will be E4. The net EMF I have taken in that loop. Now it's time for potential drop. So come from A to B. Now leave the EMF. Only discuss about resistance and current. When we are going from A to B, direction of current is from B to A, and I am proceeding from A to B. So current will be taken as, according to our rules, negative. So it will be equal to minus I1 R1. When we are moving from B to D, again current is opposite. I3 R5. Now we are moving from D to A, again it is opposite. Minus I1 R4. Now this becomes an equation. In this way, you can apply for loop B, C, D, B. You can also apply for the loop A, B, C, D, A. And you can develop the equation using first and second law. These equations are very important. If you are able to develop the equations in a particular loop, and for different types of loop you are able to solve the equation using sign convention. That means in any numericals you have solved 50% of the questions. So first try to develop the equation according to sign convention. Now we are going to apply a Stone bridge.